This content is brought to you by Mazunder Academy.
Hello everyone. We will study subset today. So my request to all of you, if you have not seen my previous videos, please watch that video first, because these concepts are a little bit continuation of the previous topics. So let's start our topic today, subset. So basically, what is a subset? Suppose capital A is a set and B is another set. There are two sets, A and B. Then we say A is a subset of B. We say, suppose there are two sets, A and B, okay, and we say A is a subset of B if every element of A is also an element of B. So in symbol, if we can write like this: A subset of B. This is the symbol of subset, A subset of B. If I give an example, then it will be clear to you. Say for example, say A equal to, I have 1, 2, 3, and say B equal to, for example, 2, 3 and 1. Then you can see every element of A is also an element of B. 1 belongs to A, 1 belongs to B, 2 belongs to A, 2 belongs to B, 3 belongs to A, 3 belongs to B. So we can write here A subset of B. Of course, you can write B subset of A also, because every element of B is also an element of A. If, for example, you have another set C equal to, for example, 1, 2, 4, 3, then in that case you can see every element of A is also an element of C. Like 1 is an element of A, 1 is also an element of C. 2 is an element of A, 2 is also an element of C. 3 is an element of A, 3 is also an element of C. Therefore, we can write A subset of C. Okay, but here we cannot write C subset of A. C is not a subset of A. Why? Because you can see there is an element in C which is not in A. For example, 4 is an element in C, but 4 is not available as an element in A. Therefore, C is not a subset of A. I can write as a note, there is a small concept of proper subset. Okay, proper subset. So what is the definition of proper subset? A set capital A is a proper subset of another set B if A is a subset of B and A is not equal to B. So actually, if we see the notation here between A and C, instead of subset, more correctly you can write a proper subset. So you can mention here in this example, like the relationship between A and C, A is a proper subset of C because A and C are not equal. Equality of two sets we already studied in the previous lecture. So two sets are equal if they have exactly the same elements. So A and C, they are not equal because there is an extra element 4 in C which is not available in A. But every element of A is available in C. Therefore, A is a subset of C but not equal to C. Therefore, we can write A is a proper subset of C. Now, if we extend our idea, is an empty set phi a subset of set containing at least one element, say P? So the idea here is, always remember, phi is always an subset of any set. Okay, phi is always a subset of any non-empty set. Okay, non-empty. Empty set we have studied last lecture. What is empty set? If a set does not have any element. Okay, so non-empty. Okay, phi always a subset of any set if the set is a non-empty set. So obviously the phi can be a subset of a set containing a single element, say P. Okay, so your answer for this question, yes. Okay, yes. Now let us see few more examples related to subset. We need to use the notation this subset to denote which set is the subset of others in the following problem. Say capital A equal to 2, 3, P, B is 1, 2, 3, PQ, A equal to 2, 3, 5, 7, B equal to 5, A equal to something, B equal to something, like this. Okay, so here set A is this, B is this. Okay, first question number 1. So check all the elements of A is available in B. Yes, 2 available, 3 available, P available, and there are some extra element in B. Okay, so we can write here what will be the answer. A is a subset of B. Actually it is a proper subset, but as it is asked us to use the notation this subset, so you will use subset. Okay, no problem. Next, A equal to 2, 3, 5, 7, B equal to 5. Since few minutes ago I said phi always subset of any non-empty set, so here you can write B is a subset of A because B is a phi and phi always subset of any set, so B will be subset of A. Then A and B, A is 3, whether 3 is available in B, yes, 8 available, yes, 9 available, and 0, yes, available. So all the elements of A are available in B, as well as all the elements of B are available in A. Therefore you can write A subset of B and B subset of A. And of course, if you have A subset of B and B subset of A, from here always you can write A equal to B. So you can see here, this is an additional part. Maybe in some other question we will be required this. So if A is a subset of B and B is a subset of A, then A always equal to B. Next question is A equal to all those x such that x equal to 2n where n belongs to natural number. If you remember what is natural number, natural number is starting from 1, 1, 2, 3, 4, like this. So in that case, what will be the elements of A? Elements of A will be all those x such that x equal to twice n. Suppose n equal to 1, then x will be 2 multiply 1, that is 2. So the first element will be 2. Next, n equal to 2. If n equal to 2, then if you put 2 in place of n here, then 2 multiply 2, it will be 4. So x equal to 4. Next element will be 4. Next, if you put n equal to 3, then 3 multiply 2 will be 6. So next element will be 6. Similarly, next element will be 8, and so on. And what about B? Set B is all those x such that x equal to 4n, where n belongs to natural number. So same idea, if we choose n equal to 1, then 4 multiply 1 is 4. So the set will start with 4. Then if you choose n equal to 2, so 4 multiply 2 is 8. So next element will be 8. Then next, if you choose n equal to 3, then 3 multiply 4 is 12. So the elements are like 4, 8, 12, and the next element will be what? N equal to 4, then 16, and so on. So now we need to build the subset relationship. So if we see, all the elements of B is available in A. 4 in B, 4 is in A. 8 is in B, 8 is in A. 12 is in B, and 12 will be there after 8, then 10, and then 12 will be there. Okay, it is up to infinity. So 12 will also be there, 12. Similarly, 16 will also be there. So what we have seen, all the elements of B are available in A. So what will be your conclusion? B is a subset of A. Or you can write proper subset. Okay, as the question is asked us to use this symbol, so we will use the symbol of subset. I hope you understand what is the concept of subset. Next, we will move to cardinality of a set. So what is cardinality? Cardinality means what? Number of elements in a set. Okay, number of elements in a set. For example, it is denoted by mod. Okay, this symbol. That means the cardinality of the set A. For example, if you have set A equal to, say, A, B, C, then what will be mod A? That is the number of elements, or it is called size. Okay, size. So of this set is 3. There are 3 elements here. Another example, if I give, say, B equal to A, B, and C, then what will be the cardinality of B? How many elements in B? 2. Because these two, A and B together, will be considered as one element. So total how many elements in B? Only 2 elements. AB will be taken as 1 element, and C. So there are 2 elements. Okay, so I hope cardinality you understand. Further we will see this. Cardinality means what? The number of elements. Next, the concept singleton set. In the name itself you can see what is the idea of singleton set. Singleton set means what? A set have only one element. Say for example, set A equal to all those x belongs to integer z such that 1 less than x less than 3. So in this set, you imagine x is an integer, and if you remember the integer line up to plus infinity and this is up to minus infinity, then 0, 1, 2, 3, minus 1, like this. Okay, now between 1 and 3, how many integers we have? Only one integer, that is 2. So this set actually have only one element, that is 2. Since the set have only one element, therefore such set are called singleton set, and the cardinality of singleton set is always 1. Okay, cardinality, that is the size of the singleton set, is always 1. So for multiple choice question, you may remember this point. Next concept is power set. So what is a power set? The definition is the set of all possible subsets of a set A is called the power set of A, and it is denoted by P of A. Power set is denoted by P of A. If I give an example, say suppose I have an set capital A equal to say A comma B. There are two elements inside the set, and if I want to write the power set of A, then what are the possible subset of A? All the possible subset of A is the power set of A. Now, as I said before, phi is always a subset of any set. So phi will be a subset of A. So phi will come in the power set, because the power set is the set of all possible subsets. After that, you start choosing one element. So first take A, one element in a set inside the power set. Next you take B. So one element choosing finished. Now you go for two element. So there is only one option, A comma B. Both the element A comma B together at a time, and that's all. So this is the power set of A. So how to write power set of A? Always phi is a subset of power set, subset of any set. So phi will be as an element of the power set. Then taking one at a time, all the possible options, then taking two at a time, all the possible options, then taking three at a time, all the possible options, and at last you can see this actually nothing but your A, the set A. Okay, the complete set, because we know any set A is always a subset of itself. Like phi is always subset of any set, and any set itself always subset of it. So these 2 points you always remember. Any set is always a subset of itself. Okay, so how to find power set we have seen. Now I will write a note here. If the cardinality of the set A is n, suppose there are n number of elements in the set A, then how many elements will be there in the power set of A? The number of elements or the cardinality of the power set of A will be 2 power n. And if we apply this note, you can see it is applicable here. In this case, what is the size of this set? Cardinality of A is 2, number of element is 2. And you can see here, what is the cardinality of the power set of A? Power set of A is, as per the rule, it should be 2 power 2, and that is equal to 4. And you can see here 1, 2, 3 and 4. There are 4 elements. Okay, so this note is important. Next, what is the power set of, this is one of the question, what is the power set of A equal to 0, 1, 2? So how to write the answer? The power set of A will be equal to, as I said before, phi is always subset of any set. Then you will take one element at a time, then you will take two elements at a time, 0, 1, then 1, 2, and then 0, 2, and then three elements at a time, so 0, 1 and 2, and that completes your set, power set. So you can see here actually what is the for checking what is the number of element in A. Number of element in A is 3, so there must be 2 power 3 equal to 8 elements in the power set of A. Understand? So you can see here 1, 2, 3, 4, 5, 6, 7 and 8 elements. So I hope you understand how to find the power set of any set. You can just take some example with 3 elements or 4 elements, okay, and try to work out and check using this note whether it is correct or wrong. Next, you see what is the power set of an empty set. So power set of an empty set, this equal to what? This is the question. And second question is what is the power set of the set phi? Okay, these are the two questions. So first let us understand, in the set phi, what is the cardinality of phi? Cardinality of phi is 0 because phi have nothing, no element inside, so number of element is 0. Therefore, how many elements should be there in the power set of phi? Power set of phi, it should be 2 power 0, that means equal to 1. So there should be only one element in the power set of phi. And what will be that element? In the power set of phi, it will contain only the phi, the default subset phi, because phi is a subset of any set and phi can be subset of phi itself. Therefore, phi will be an element in the power set of phi. Okay. Now come to the second question. What is the power set of set phi? Now again, if I ask you, what is the cardinality of set phi? How many elements inside this set phi? It is one element, which is phi itself. Okay, here phi is acting as an element of this set. So how many elements should be there in the power set of set phi? In the power set of set phi, how many elements should be there? It should be 2 power 1, and that is equal to 2. So let us write the elements. Therefore, power set of set phi will be equal to, always we know phi is a subset of any set and the set itself. So this will be the power set of set phi. So I hope you understand these two questions, important questions. And the last concept is universal set. As the name itself suggests us, universe means the whole. So what is an universal set? How to define universal set? The set of all possible objects or elements under study. For example, if you are dealing with letters, then Okay, one more point. It is denoted by capital U. Capital U is the notation of the universal set. Okay, U. So if you are dealing with letters, then what will be your universal set? Your universal set will be all the letters A, B, C, all the letters up to Z. Okay. If you are dealing with natural number, then all the natural numbers will be your universal set. If you are dealing with students, then all the students of your school or of your class, depends on your question. Okay, that will be your universal set. So I think I have reached to an end of the theoretical discussion. In my next video, I will take the exercise 1.2. Thank you so much for listening, and please follow my previous videos and the next videos to make it clear. If you have any doubt, you can reach me through this email, mazumdaracademy@gmail.com. Thank you.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.